My dear kids, welcome back for the next session of science. Okay, this is Mithun Raj, your science teacher, and I'm welcoming you for the to the world of physics. Sorry. So, what we are discussing? We are discussing about laws of motion. Okay, we already finished the two laws, the first law and the second law, and we already studied about force and some applications of both the laws. First law is about inertia, second law is about momentum. Understand? The third law is about action and reaction. Understand? Action and reaction. What is action? What is reaction? Understand? For example, if you throw a stone at a dog, what will be the action and what will be the reaction? And it is a very strong dog which bites people. Tell me what will be the action, what will be the reaction? If we throw a stone at at a dog, the action will be throwing the stone. Reaction will be the dog will bark at you or dog will bite you. Understand? So understood what is action and what is reaction. Before studying this chapter, not chapter, this part, you must know what is action and what is reaction. A lots of applications are there. Okay, regarding this third law. Third law is very simple. Only this much. See, to every action there is an equal and opposite reaction. It's as simple as it is. Isn't it? Third law is easy or not? Every action there is equal and opposite reaction. Only one time if you hear means you won't forget it. Understand? That is the third law of motion. Every action there is equal and opposite reaction. These are some of the applications we will study. Aeroplane, helicopter, this is rockets, ship, boat, lawn spray, that rotating sprinkler and all. Everything is working because of this law. Let's see. Newton's third law of motion says, whenever one body exerts a force on another body, the second body exerts an equal and opposite force on the first body. For example, if I am hitting the table, understand, like this, how much force I exerted to that table, the same force the table exerts back on me. Understand? That is called as the reaction. Understood? The force exerted by the first body is known as action. The force exerted by the second body is known as reaction. Understand? In this case, we are pulling this, what do you say, this one? Spring balance, isn't it? We are pulling this one. We are exerting force here. The same amount of force is being exerted by this hook in the opposite direction. That is called as the reaction. A simple example is bouncing a ball. How the ball bounces back? If we put a ball down, a rubber ball, it bounces back. Understand? Going down is the action, bouncing back is the reaction. That means equal amount of force is being applied by the floor on the ball also. That's why the ball is bouncing out. By giving example, you will understand. How we are walking. You know how we are walking. How we are able to walk. While walking, our feet touches the ground. Any doubt regarding that? Okay, no need of any doubt, because you know that our feet is touching our ground. Actually, what we are doing while walking? Actually, we are trying to pull back the ground. Understand? We are pushing the ground backward. But in that case, ground is more bigger than us. So we are moving forward. Understand? The action is, we are pushing our leg backward. And reaction is we are moving forward. See, in this case, what has happened? Acceleration is A. Attraction of earth players weight, leave it. See, vertical component of the force of the floor. This man is putting pressure here. Understand? See, he is putting pressure on this side. Reaction is the front forward movement. Understand? Like this, we won't understand. Leave it. When we walk on ground, then our foot pushes the ground backward. The forward reaction exerted by the ground on our foot makes us to move. Understand? Simply, if we are standing means what is happening? Our weight is on the ground. Understand? Our weight is on the ground. The ground is exerting equal amount of force upward. That's why we are standing there. Okay. Otherwise, what will happen? We will go down. In the case of water, can we stand on water? No, because the water density is very low. So if we stand on water, our force, our weight is exerting force on that water. But the water is very, very weak because it has no density. So that much force is not being exerted by the water on our body. So we go down into the water. But in the case of land, land is strong. Understand? While we are walking, what we are doing? Our foot pushes the ground backward. But the ground is bigger, so we are the forward reaction will come to our body and we are able to move. Okay. Another one is recoiling of gun. See what is happening here. A man fires a bullet. Understand? In movies and all, you have seen simply these people simply they are what? Dum 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 dish, isn't it? They are firing thousands of bullets from a single gun. Am I right or not? But actually, if you are not a professional and you don't know how to shoot a gun, whenever we are shooting one bullet out, that much amount of reaction is occurring backward also. Okay, action means bullet goes front, reaction means it comes back. That is called as recoil velocity. Okay, recoil velocity. The gun comes backward, that is called as recoil velocity. Understand? The same thing is happening in every gun. Okay, lots of pressure is coming backward also. If we are not correctly balanced, we will fall down after firing a shot from a gun. Understand? That is called as recoiling of gun, and that velocity is called as recoil velocity. When a bullet is fired from a gun, the force sending the bullet forward is equal to the force sending the gun backward. But due to high mass of the gun, it moves only a little distance backward and gives backward jerk or kick to the shoulder of the gunman. Anyway, bullet is very small, gun is big. So bullet will move with high velocity and gun will move with less velocity. Understand? In this case, the force exerted on the bullet and the force exerted on the gun is same. Understand? Force is same, mass is different. Okay, gun has more mass, so less acceleration. Bullet has less mass, so high acceleration. Understand? According to the law. Okay, now it is a bit difficult to understand, but I will check one more time the note, what is written in that note, and I will give another examples for this one. Okay, just try to study the definition. Lots of applications are there. See, rocket. How rocket is flying up? Actually, the gases are burning at the bottom of the rocket. Understand? Lots of fuel is being burned. When fuel burns, what will happen? It will become fire, and fire is pushed downward. Okay, and a huge force is occurring there, and that force, when it hits the ground, it will make a reaction, and that reaction takes the rocket upward. Understand? Yeah, same thing happened in the case of this aeroplane. Air is flowing. When this wings of the aeroplane hits the air, the reaction of the air will help this plane to go upside. Understand? This all rocket science and all is very difficult. Leave it. But all these things are being applications of the Newton's third law of motion. Okay, aeroplanes, jet planes, ships, rockets, motor vehicles, even we are walking now, that is also the application of the third law of motion of laws of motion of. See here how they are rowing the boat. Have you seen ships or boats? How they are rowing? They are pulling this in the opposite direction so that the boat will move frontward, isn't it? Have you seen this rowing? That is also action means they are rowing the row. Reaction is the boat moving forward. What will happen to this guy? Simply he is going to step into this floor, but he is exerting a force backward, but the mass of the boat is not that much high, so this boat will go in this direction and he will fall down. Understand? Simple examples, leave it. Last one is law of conservation of momentum. This is very, very important. Okay, law of conservation of momentum is very very important, and it is also is a mark questions will come from this part. 100% questions will come. Okay, I will make it a bit more bigger. Law of conservation of momentum we will study next class, because some technical problem occurred for the camera. It is not shooting correctly. Understand? So my dear kids, what you want to do? You want to go through this video and some examples regarding, say, third law of motion, because third law of motion is very very difficult, not difficult, very very important and interesting also. It is simple or not? See, third law of motion, for every action there is an equal and opposite reaction. Is that simple? Yes, it is as simple as it looks. Understand? Lots of lots of applications are there regarding this third law. Okay, this is the sprinkler in a garden and all. Have you seen sprinklers? Same, Newton's third law. Understand? This the water is coming out of one place. See, like this, and the force of the water will allow the sprinkler to rotate. Understand? Lawn sprayer, it's called as the lawn sprayer. This is the rocket. This force, this fire is going down. Okay, jet of hot gas is going down. The reaction from the ground makes the rocket to go up. Understand? This is the motion upward. Reaction also is coming here. Okay, see, these are the some of the examples regarding this. I hope this is a interesting chapter. Too many numericals are not there, but numericals are there regarding acceleration, mass and momentum. So bye bye my dear kids for today. Next day we will meet with another class and we will finish the class. Okay, one more class means this chapter is finished. That means almost 6 chapters finished. Almost half part of our entire textbook is also going to over. After that we will start a new chapter of chemistry. Okay, bye bye my dear kids. Stay at home, stay safe. Bye bye and Jai Hind.